No. All right, sorry, Hales. We ended up
Dying
here. Okay, let's plug 3 in. I haven't plugged 3 in. You guys probably did. 3. 3 times 3 is positive. 3 minus 2 is positive. So that's where he is positive and he is increasing. Okay. Now let's do second derivative. Okay, I'm going to still plug in -1. But I'm going to plug him into the second derivative. So -1 times -1 times 6 is -6 minus 6 is a negative number. So he is Oh, wait. He is concave down. Okay? Now, we said that these two had to be the same as each other.
Can you just pause for a second?
Yes. Sure. Okay, now, we said that these two had to match each other. So this one should be concave down as well, but why? Do you understand why?
Because 0.5 is 3 minus 6.
0 was not a critical number for my second derivative. That means he's not going to change concavity at 0, right? Okay, but let's do that. 0.5 times 6 is 3. 3 minus 6 is negative. That means he's concave down. Okay? All right, 1.5 into 6. That's 9 minus 6, which is positive, which means he is concave up. 3 goes into there. That's 18 minus 6, which is 12, and he is positive, so he is, so he is concave up again.
I just have con and then I down or up arrow.
Now, is that consistent with the graph? Increasing, decreasing, increasing, right? Then he is concave down until he gets to here, and then he's concave up until he gets to there, right? Yeah, that's what we have.
Decrease occur though.
Decrease.
Right
Okay, right here. This is increase, Josie. Watch. This is decrease until he gets to there. Then he's decrease again. Then he's increase. Make sense?
Just derivatives.
Yes. That's like he switches.
Concavity.
Yeah, he crosses the point of inflection and he doesn't switch directions, right? Okay. Good. Let's skip example 6.
Yay. Get out of here.
And 7 and 8.
Let's skip example 7. Let's go to example 8.
Yay. Skip 7.
Blah, blah, blah. Let's skip example 7. Let's talk about example 8.
Blah, blah.
And that'll be it. Hey, look at that.
We only have to find the inflection point.
This one says find the inflection points. Okay, what is an inflection point?
Literally where they mess up.
Where it switches concavity. And which derivative is concavity? The second derivative. So we don't even need to do the first. Well, we do need to do the first derivative, but we don't need to do anything with it, right? Just second derivative. So first derivative, f prime of x equals 4x cubed. That's my first derivative. Double prime is 12x squared. Then what?
Then we set equal to 0.
Set it equal to 0. Divide by 12.
0.
X squared equals 0. Take the square root.
0.
X equals 0. Okay. And so if I want to do my whole table thing,
Plus or minus 0. Yay.
I'm going to go from negative infinity to 0. From 0 to infinity.
We don't need to do that.
What?
We don't need to do that.
Well, he's probably going to be a point inflection, yeah.
Wait, but what? Wait.
But I'm going to show, yeah. So we could just stop. 0 is my point of inflection. Yeah.
No, go
Right.
away.
Okay, so if we pick a test point, let's pick -1 and +1. Okay? Into double prime, 12x squared.
I don't know how to do it.
If I plug -1 in, I get a positive. Wait a second.
No, you can
Wait a
No,
second.
you can pause it. Count how many.
Wait a second.
That's why we go
Wait a second. 12x squared is my derivative, or my second derivative, right? If I plug -1 in there, I get a positive, right? That's my second derivative. If I plug a +1 in there, I also get a
Because they're the
plus,
same concave.
which means he's concave up, and then he's concave up again.
So it's 9.
So this guy was not a point of inflection. Because he's not switching concavity. Look here. Is he a point of inflection? So it's just the vertex, right? Okay. So I have no POIs.
Counting the ones on
No poise.
No poise, because he doesn't switch concavity. Hey, look at that. That's kind of exciting.
That's why we went all the way.
That's why, yep, you're right. We had to check him. Because sometimes he doesn't end up being a POI. Huh? Interesting.
I don't have my book.
I also think I have one.
I just
Good.
wanted to go all the way because we had already drawn the graph.
Woo!
In your backpack. Are you such a
Alright, goodbye, Haley.